Okay, this is going to be a series of tutorials looking at how to group together certain graphics into like a tile and then populate a whole entire canvas with that tile and also input some random variables so we can get some variation out of that process. In it, I think we want to see how we could write our own little custom functions. We want to figure out how to use the push and pop matrix to move things around the screen, as well as some other little enhancements of how to randomize this a little bit. So let's get started. I have an example sketch right here. I just have setup and a basic draw. I'll go ahead and press play. And you can see I've drawn a rectangle with some rounded corners. I'll talk about that here in a second. Into this corner, right? So we have a background, the stroke weight, and a color. So this is, I'm going to try to do most of this grayscale, add some color towards the end, but I am using some transparency. And then this might look a little odd. Let's go over to the documentation under the 2D primitives and check out, oops, not that one, rectangle. So you can see we have rectangle, which we've been dealing with in class with an X and a Y, and then its width and height. We can also add a fifth parameter, which just bevels the corners, or we can, and this is basically a radius, and then we can do the same for each individual part. And if we look at the documentation, we see top left, top right, bottom left, right? So as it works its way around from that origin, which is the default in the corner. You can, though, change the mode. You can see here rectangle mode corner or rec mode center, which would control where these are drawn, right? Okay, so we'll come back to that. Let's go back to the top reference page. So I want to draw multiples, right? And my idea here, this, when I'm drawing one rectangle, this is not really the tile itself. This is just one element. The tile itself is going to be a larger, kind of a pinwheel that I'm going to draw. So let's start with creating our own custom little function. And let's copy all this, cut it actually, and put it in the scene. And if I press play or run, I get nothing because we haven't told the draw to actually run anything. And keep in mind when we write this out, when we say tile, processing does this all the time, and you're used to saying like ellipse, right? Or rectangle, okay? So you put those commands, and obviously they have parameters or arguments that get fed into those. We'll talk about that a little bit later. So let's go, just press run again. You see we have this working. Okay, let's close. So we want to draw multiple little rectangles here. For now, I'm going to leave this stroke weight and fill up above, okay? And let's just do for integer I equals 0. And let's say I is less than 360. And I, now normally we have done, at least in class, plus plus. So let's do plus equals, which just means it's going to iterate and add to itself. And let's do it in increments of 10, right? And let's have an open and a close bracket. Okay, so this is going to iterate through, and if I run through this, you get what looks like a very ugly line right here, because it's just drawing the rectangle on top of it. What I want it to do is actually pinwheel and spin across this little area. So we're going to do, in fact, let's go over to the tutorial section. You will want to check out 2D transformations. And this talks about how processing moves things around the page. I always imagine the processing sketch is a whole bunch of layers, like a piece of transparent paper sitting on a pad. And we can make a drawing, and make a drawing here, make a drawing here. But the way we deal with transformations is we draw something onto one layer of this pad of paper, and then we tear that off and we move it to wherever we want on the screen, and then that drawing or whatever drawn elements are on that layer get moved in that screen, right? So this is still the processing main window. We're just moving the matrix that the graphic element exists on. Sounds pretty cool, right? So I would advise that you move through this and look at some of the documentation in the tutorial. The other thing too you'll see in the rotation is that processing does all these rotation calculations in radians, which are different than degrees, and you have to type things like pi divided by 4 or pi divided by 2. And I see this a lot in tutorials, and honestly I think it's kind of confusing, and it's easier for most students to deal with degrees. And so we'll talk about how to convert, right? So let's go back in here, and in the tutorial it talks about the fact that there's two new methods here, push matrix and pop matrix. So this is a way of telling processing. We'll do push, pop. So if we were doing, we're going through this iteration and we did not use push and pop matrix, and let's say we did something like translate. Let's just say translate I, and we'll leave that at, we'll do I as well for that one. Oops. And let's comment out these two. So you can see what happens is the amount being translated is compounding itself. It's moving over and over again. So it kept moving across the screen because I didn't use push and pop matrix. Oops. So what you see here is a nice incremental repetition in the drawing, because what it does is it moves it 10 units in the X and Y, and so push matrix says, hey, I'm graphic elements, I'm about to move you somewhere. Then it translates it, it draws the rectangle, and then it says, you know what, I'm done. I've now made that drawing. Let's reset the matrix back to the origin. So as when we go through the loop here, we get 10 to 10, 20, 20, 30, 30, 40, 40, 50, 50, blah, 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 all the way through here, right? So I would just say, when in doubt, just use push and pop matrix until there's a reason why you would not want to use this. This is just a way of bracketing and containing those transformations, right? So I'm not going to use translate in this one. What I want to use is rotate. Rotate. And if I just put I in here, in this instance, it will look like it's maybe doing the right thing, but trust me, it's not. So anytime we put in rotate, we want to use a degree. Just use radians. So what we're doing is we're recasting that value of degrees and converting it into radians, so processing knows what that number would be, right? So if we were to spit out this number, you would get 1.376 or something in radians, which might equal 80 degrees or something like that. And since we use degrees in all of our 3D applications that we use in our program, this is the easiest way to do that. So I'll go ahead and press play, and you can see it's off the screen here, but I have a nice little flower petal going on, right? And the reason I didn't put these in here is because for right now at least, I'm going to be using the same stroke weight and fill for each one of these rectangles that I draw. So there's no reason to restate code that's already stated, right? I don't need to tell it again to use that stroke or that fill. I've already done that. It's like a state machine, so we'll just leave it there. Right. So that's the first thing. Let's move on so we can get this done in time. For part one of this, let's go up to the top. Integer. This time we're going to do a for loop, and this time we'll say x. And we'll say that x is going to be less than the width. And we'll say x plus equals, and this time we'll say 100. And I'm using that because that's basically the size that we're using for the rectangle that petal that's in this the tile, right? All right, so we have this iteration, and we'll do this over and over again, but again, we want to move it across the screen, so let's just do a little convenient copy, paste, copy, paste, and this time we are going to use translate, and let's say whatever the X is that we're using there, and we'll say 0 for the Y. And we'll do a little auto format. And you can see we have these pinwheels moving across the screen now, right? One thing you'll notice is here at the beginning, we started at 0, and it did the first one, it's working away, but it didn't give us that last one that goes off the edge, right? And the reason is because in the for loop, we've said X is going to be equal to 0, and as long as it's less than the width. Okay, so when it tried to draw that last one, because we were going in increments of 100, when it tried to draw that last tile, it said, nah, because it's not less than the width. So let's amend our little conditional statement to say if X is less than or equal to the width. Okay, so we've completed that row. So how do we make it go down in this direction? And for some of you, this might be your first example of a nested for loop. You might want to check out the tutorials that I have on YouTube about for loops in particular, and thinking about how these can happen inside of each other. So here we would say, let's go through the first time, and if this is still true, go ahead and do the function that's inside of that. And so the next function would be to do another for loop, and this time we're going to say y. And I guess we should say height. So we can get here and then work our way down, and get to here and work our way down, and here, and so it would fill up the whole entire screen. You can see now we have that tiling pattern across the whole entire screen. I think this is where we're going to end for part 1. I'll come back in part 2, and because this is working, we're getting some intricate pattern, but it's not randomized, right? It's a little boring. That we certainly could do things thinking about, say, the fill here. Maybe this is something like 10. Right, so you can get more dense line work on top of everything that's going on there. So that's something we can play with in the next tutorial. Let's try one more. All right, so lots of different things. We're getting some intricacies in this, but we need to add some randomness. So this will be part 1. I'll see you in part 2.